Uh, so these are some past paper questions from motion.
Mm-hmm.
We have done most of the MCQs. We will try some of the structural questions, theory questions today.
Okay.
And then we will start a new topic. And
Okay.
I've planned this a 2-hour class today, okay? Because we are not able to connect in the previous week. Bus
Yes.
travel at the constant speed. It stop for the short time and then travel at the higher constant speed. Okay, so you have to plot the graph using the axis. Draw this distance time graph for the bus journey. So bus travel at the constant speed. Constant speed का मतलब क्या है कि आपके पास keep in mind कि it's a distance time graph. So whenever we
Hmm.
have a distance time graph, constant speed mean it should be a straight line. ठीक है, we have to keep it in
Yes.
mind. And okay, if start for the short time and then travel at the higher constant speed. Okay, so how you are going to make the graph? Initially a constant speed for the short time interval as they write over there,
Yes.
and then travel
So
at
we
the
draw.
higher constant speed. Then your graph again constant but higher. That means your
Hmm.
speed is now increases. So your graph should be like this. Now let's see
Wait,
the
don't we have
marking.
to draw? Don't we have to draw like where it stopped?
Uh,
Where the where
Wait a
it
minute.
stopped?
Yes, you have to draw till the whole journey. So because we haven't measured the time intervals, so
Hmm.
you can draw it till over there if you want. Could be like this, and then steeper straight line like this till the end of the journey.
Yes, like this.
Okay.
Yes.
So the marking according to the paper, I will share this handout with you along with the marking. So I have my marking of this question in my hand. From the time zero, the line constant positive gradient, not necessary from the origin horizontal line, from the end of the sloping line. Line of the steeper positive gradient. तो हमने दोनों बना दी हैं, number 1 भी बनाई है, and then we have made the steeper positive gradient from end of the horizontal line. So we have done this according to the marking. So part number B, this is a speed time graph, and
Yes.
lift elevator start from rest at the ground floor of a building. Is
Hmm.
the speed time graph for the motion of the lift to the top floor of the building. Okay, so till the top floor, this is the speed time graph. Use the graph
Yes.
to determine the distance from the ground floor to the top floor of the building. आपको find out करना है distance. And this is the speed time graph. So how can you find out the distance? By
Hmm.
speed time graph.
Area under graph.
Yes, area under graph. Very good. Which
This
shape
is
is
a
this?
trapezium, so it will be
Trapezium.
base 1 plus base 2
Very good.
over.
So now half height and then sum of two parallel lengths. What are the parallel lengths? Number 1 parallel length and number 2 parallel length. So if I'm talking about length number 1, so it's 25. But if I'm talking about other length, so I can find it out. So it's 20, and this is somewhere like this. So it is in middle
Hmm.
between 5 and 10. Let's make it more accurately. Okay. So in middle we have this is 6, this is 7. 7, then 6, 7. Yes, you can take it 7.5. This middle
Yes,
length
okay.
is 7.5. Okay, so
Yes.
7.5 and this is 20. So what we can do? 20.5 and our answer will be,
I think it will be 13.5.
yes, it's 12.5. Okay,
Sorry, yes,
12.5.
12.5.
Okay, so 25 plus 12.5, we will add up both and it's 37.5. Now height is, let's see the height over there. So this is above 3 and 2, 3.1, 3.2, 3.3. This is 3.3. Yes, 3.3. Multiply both and then divide by 2. So 37.5 multiplied by height. Height is 3.3. So
Yes.
value is 123.75 divided by 2. Now let's divide by 2. And our answer is, yani distance is 61.8, which is equals to 62 meters. So this is our desired answer.
Yes.
62 meter. And this is exactly same in the marking. Marking exactly shows all the same values. So we have done accurately. Now 1 mark for the formula, 1 mark for substitution of value, and 1 mark for your desired answer.
Okay.
Done?
Yes.
Okay, now let's move to the other question. Okay, at a sport event, a champion runner and a car take part in the race. Okay, so we have a race between champion runner and the car. The runner run at the constant speed of 10 meter per second. Okay, now we should keep in mind it's a distance time. It's not a distance, it's a speed time graph. And for speed time graph, constant speed means straight line. And your constant speed is still 10 meter per second. From the
Yes.
start to the from the start of the race, So during the first 5 seconds of the race, the car start increases. So till the whole journey, the runners have a constant speed. And when we are talking about the car from the first 5 seconds, so for the first 5 seconds, the car speed is increases from 0 to 25. Okay, so car speed is actually increases at the constant rate. So whenever we have a constant rate, we have a something like this straight line. So we need to have make this type of graph on the given graph. So now let's start making the graph. So first of all, we are going to make for the runner, which is 10 meter per second till the end of the journey. Okay, done. This is we have done for the runner. Now let's do for car. And desired speed is 25. So R25 is in between of 30 and 20. So 21, 22, 23, 24, 25. So this is 25. Now I'm changing the color. That means I have to make a straight line till that point till 5 seconds. So from 0, 0 till 5 seconds, this is the straight line.
Yes.
So this is the graph that I have to make for the runner and for the car. Okay, you can see one thing. Both the graphs are meeting, yeah, intersecting at a single point. Let's mark this point, X.
So how do we know which one is the runner, which one is
I have
car?
changed with the color. The runner is having a constant speed that is shown by the black color in the graph,
Okay, yes.
right? And the car increases speed from 0 to 25 at the uniform rate. So I have shown it with the red color. All right.
Yeah. Yes.
Okay. So now you have to find out the distance. The distance traveled by the runner for the distance for the runner in the 5 seconds. So I'm moving the graph up again so that you can see for the runner.
They're both triangles, no?
Okay, so whenever we are talking about runner, they have a constant speed. That means you have to use the black line, and it's a speed time graph. So that means we are going to use distance under the graph, area under the graph, and this is the
Wait, so we need area under graph, and they're both
horizontal
triangles.
shape, right? So length into
Yes.
breadth. Length here is
Okay.
10, and breadth here is 5. 5 into
50,
10,
50
50.
meters.
Yes, 50 meters. So this is the right answer, 50 meter.
Yes.
We have done rightly, okay? Now you have to find out the distance uh for the car. Okay. I'm not removing the graph. Let's see what is the question is. The distance traveled by the car
In 5
in 5
seconds.
seconds. So now we have a shape which is triangle. Okay. So this shape is a triangle.
Yes.
So we moving this and I'm shading the area.
Area equals base times height.
This is a triangle shape and now use the
Yes.
formula of a triangle.
Base times height.
Yes.
The base is 25. If I'm not mistaken.
It's 25
Sorry, the height is 25, base
and
is
base is 5
5.
divided by 2. 25
75
into
over 2.
5.
I think 75 now.
Yes. So 25 into
75
5
over
is
2.
70. Okay, well, 125 divided by 2.
Sorry,
125
125
divided
divided by
by
2.
62.5.
Yes, 62.5.
Okay, now let's see the answer. Yes, exactly same. 62.5 meters. So we have
Yes.
done this rightly. All these steps are done according to the marking.
Yes.
Okay. The time at which the car overtake the runner. Overtake the runner. I told you whenever we are making the graphs that there is one point which is intersecting both the graphs.
Yes.
So I think that is the time which is mentioned. That is 4, I think. No, that is 2. That is the point. Let's make it again.
Yes.
10. And then you have 25. That means till this point. So straight lines. So the point of intersection is 2. So the time here is 2. 2 seconds. This is the correct time where they both intersect, they both cross each other. Okay. So this is 1 mark question. Now let's come to question number 3.
A comet traveling in space enters the atmosphere of a planet. Figure 3.1 is the speed
Okay.
time graph for the comet from time t 0 seconds.
0. Okay. So that is the time at which the comet is actually come into the atmosphere of a planet. Okay. So first of all, during the time 0 to 6 seconds. So 0 till 6 seconds are in between 8 till here. I think we have a 6 over there. Both the speed
Yes.
and the comet and the velocity of the comet remains constant. And we can see that it's constant because till
Yeah.
6 the line is exactly straight.
Yes.
What does suggest about the motion of the comet? What do you think? What is the motion of the comet at that point?
This point, I think it's like decreasing speed because like it's going down.
This is the point, state what this suggests about the motion of the comet. During this point, we have a constant speed. What do you think? Constant speed, right? So if the
Yes.
speed is constant, what happened to the acceleration of the comet?
Speed is constant. The acceleration?
Acceleration, if velocity is equals to constant velocity, then at this time our acceleration is equals to 0 because there is no change in the velocity. So you just have to write this, that at this time speed is constant. That's why the acceleration is constant. Okay.
Is the
acceleration is
acceleration
0,
or
not
is it
constant.
constant? Yeah, 0.
Okay, so this is
So
one mark
it's not
question.
accelerating, but
Yes.
yeah. So velocity, okay.
Okay. Now determine the distance traveled during the time 0 to 6. So you can see this is again the speed time graph, and we can find out the distance
We
by
need to
using
do area under graph now.
area under the graph, and this is the point where we are going to make. Okay. So this is 6 and this is what height here is 1200, 20,000, 30,000, 30,000 and 500. So this is 30,000 and 500. What do you think?
Yes.
30,500. And this is the rectangular shape. So we are going to use the formula of length into breadth. Length here is 30,500. Breadth here is 6. Multiply both.
Let me check. I'm getting 183,000.
Yes, right. One, two, three, four, five, six, 7. But no, it's not 35 and 500 if we count the small boxes. This is 30,000 and 100, 30,200, 30,300, 30,400, 30,500, 30,600, and 30,700. What do you think? It's 30,700. So now we need to change the values.
Need to change values?
Actually, it's not 30,500. This is 30,700 because we have 6 small boxes, but the 6.
So it's 6,000? 600?
Right, so we will change it 600 multiplied by 6. And again, the answer is 183, then 600 meters.
Yes.
Right? The procedure is same, just we need to calculate the small boxes, which are equals to 6. Okay.
Yes. Okay.
Now part number B. Explain what the graphs show about the motion of the comet during the first 6 to 10. Okay, now they are asking about it. Explain the graph. Now you have to analyze the graph from 6 to 10. Okay, from 6 to 10 seconds. So 6 here, we have 6 here, and 9, 10, 10 here. Okay. So between these points, let's see the motion of the graph. What do you think? This is which type of graph?
Wait, the slope is going down.
Yes,
Slope is
it's
going down.
decreasing slope. So what does it
Yes.
show?
Motion is decreasing.
First of all, we have acceleration here.
Acceleration,
Maximum acceleration. Then
yes.
speed is decreases. Right?
So will the acceleration increase?
Yeah.
Velocity decreases, acceleration
is increases, but in the negative direction. So what you are saying, there is a deceleration. Right? So here
deceleration
we have a
increases wait, deceleration increases, velocity decreases.
Yes, exactly. So that's why we have velocity, decrease in velocity. So number one, we have to write the point that velocity decreases. 1 mark. Decreases. And we have deceleration.
Okay.
Okay. So 2 mark question. Both key terms are mentioned here.
Yes.
Determine the acceleration of the comet at t 11 second. Now you need to find out the acceleration from the graph. Okay, now let's see which method we are going to use here. This is number C part. You are going to use the formula.
V final minus V initial over time.
Yes. And time is given to you, which is 11 second. So first of all, we need to find out 11 second kahan par hai. So this is 10. This is 10. And we have 11 over there. So this is the point, we have 11 over there. And at 11, this is the point of velocity. So let's count 10,000 and 100, 10,000 and 200, 10,000 and 300, 100, 200,
I think it's
300,
18,000.
400, 500, 600, 700, and 800. So this is 10,800. Okay. So
won't it be 18,000?
Sorry?
18,000. Won't it be 18,000?
Oh, sorry. Yes. 18,000. All right.
Yes.
Because we have 20,000 above. Okay. So this is our final velocity and this is our initial velocity. Now we are going to find out, use the formula. Change of velocity over time. V minus u divided by t. So 1 mark for the formula. Now substitution of values. So 0 minus 18,000 divided by 11. Let's find out the value. But it's obviously in the negative because it's deceleration.
Yeah.
Divided by 11. So our answer here, acceleration is 1636.36 minus meter per second square. So this is the value. Which is right. This is under the range which is given by the examiner report. Okay. Now let's move to the other question.
Okay.
Now part number D. Suggest what happened to the comet at 12 second. What happened to the comet at 12 second? Look at the graph. Yes, at 12 second, you have straight line.
Can
Straight
I
this.
see full graph picture?
What does it shows?
Straight line. It stops? Does it
Yes, it
stop?
stop or it hits the ground. Okay, so it suddenly
Yes.
stop and that is the point where the comet actually hit the ground of the planet. ठीक है, तो हम यहाँ पे क्या लिखेंगे? It hits the ground, yeah, it hits the surface. Both are right. Okay. Now let's come to question number 4. Interpretation of graph. A plastic ball is dropped from the balcony of a tall building and fall towards the ground in the straight line. The speed time graph of the falling ball. It's a plastic ball, so eventually it will come to the terminal velocity, and it is falling from the tall building, so definitely it will come to the terminal velocity. State and explain in terms of forces what happened to the speed of the ball between time 2 to 3. So what do you think, what happened between time 2 to 3?
I think it's stopping, no? Like,
Speed time
it's
graph.
constant.
Yes,
Is it constant?
it's a constant speed. That mean whenever we have constant speed, what we call it?
Straight line.
What is the name of the constant speed? Terminal velocity, right?
Terminal
So that is the
velocity. Yes.
point where our ball achieves the terminal velocity. So what you are going to write for the 3 mark or 2 mark, that's a 2 mark question. So here velocity is constant. 1 mark for writing constant velocity. That is the point where acceleration is equals to 0. That's it. And that is the point where both the forces, weight and air resistance, is also 0. So weight is equals to air resistance. So I have used a symbolic form here, but you have to write in the form of wording because symbols are not allowed in Cambridge.
So, wait, what did you write? Acceleration equals 0?
Yes, you have to write the whole wording. Right, acceleration is equals to 0, and at that time weight become equal to the air resistance. So you have to write it in the wording form.
Okay.
Symbols are not allowed in Cambridge. Okay, keep in mind.
Okay.
So part number B. Mark a point P on the line where the acceleration of the ball is not constant. So where the acceleration of the ball is not constant, what is the point?
Let me see. I think, let me
Okay.
see.
What do you think? What is this
1?
point?
Is it 1?
What happened between 0 to before 1?
Before 1, it's not really constant. It is like increasing speed. You can
Here
say, but
speed is
not
increases,
constant.
but acceleration is not constant because it's a free fall
Yes.
motion, right? It's a free fall motion, and there is a point where ball is falling, so velocity is increases, and
Mm-hmm.
here object is accelerating. So that is the point from this to this, we have acceleration in the object, and that is the
Mm-hmm.
point where velocity constant and acceleration is 0.
So
So
I have a question. What about the acceleration, like before 1? Is it increasing?
acceleration is decreasing at that time. You can see the graph that initially the velocities increases,
Yes, but the acceleration
that you have a
decreases.
decreasing gradient. Decreasing
Yes.
gradient shows that acceleration is start decreasing at that point because the velocity is also decreasing that point, right?
Yes.
And then eventually it will come to zero,
Mm.
right? So where we have
Yes.
acceleration, you can write uh, the values between which are according to the marking. The points are mentioned here. These are between 0.25 second to 1.9 second. So you can write any point between 0.25 to 1.9 सेकेंड. सो व्हाट इज द 1.9? यानी कांस्टेंट वेलोसिटी से पहले पहले का आप कोई भी टाइम दे सकते हो, because in throughout there we have acceleration, but after here we have zero acceleration.
Yes.
If you write even 1, you are right. Okay, if you give me the
Yes.
answer 1, so that is right, because this is the answer is in between the range.
Yes. Okay.
Okay. Now calculate the acceleration of the ball between 0 till 0.25. So we need to find out the acceleration between 0 till 0.2.5. So let's count the number of small boxes first of all. So here 2 boxes equals to 0.1, then 0.2, 0.25. I think here 0.1, 0.2, 0.25. Okay. So this is 0.25. 3, 0.
Yes.
Let me count again. 1, 2, 3, 4, 5. Okay, I'm right. So this is the
Mm.
point. We need to find out acceleration. So what is the velocity at that point?
The velocity is
2.2, 2.4, 2.6, 2.8, 2.4.
uh, yes,
This is
2.4.
2.4.
Yes.
And time here is 0.25. Okay, find out the
Mm.
acceleration at that point. Again, the same formula. 1 mark.
V
Now,
final minus V initial
yes.
over time. 2.4 minus 0 over 0.5.
Hmm.
Let's see.
So it will be 2.4 divided by 0.25. 9.6 exactly. बिल्कुल ठीक आ रही है.
Divided by 0.25?
Yes.
Isn't... I'm getting 9.6. Is it correct?
Exactly. You're right.
Mm.
And your desired answer is also 9.6 to 10. So there is a range according to the marking. Your answer should be in between 9.6 till 10 meter per second square. So हमारा 9.6 आ रहा है, that means our answer is correct.
Yes.
Estimate the distance that the ball fall in the first 3 seconds. Estimate the distance. Okay.
Can we see the graph?
So it's a velocity time graph, but they call it estimate. You know why? They don't
Why?
says you to calculate the distance, because you have a curved straight line here. Until now we done the shapes like this: trapezium, rectangle, but this shape, it's not
So we draw a
a
square
proper
most of
shape.
the time, so...
So right, so you are not able to find it properly, but you can estimate it by using counting the number of boxes, right? So let's see what is in the marking. They just write here area under the graph. and they use the formula. This is question number 5, right? Question
Yes,
number
I
4.
think 4.
No, 4. So area under the graph, then attempt at counting the squares between 16.2 to 17.5 meters. So you are going to estimated answer they are asking for you. So what we will do, we will count the number of boxes here. So we can do exactly for this because it's a rectangle. Like from 1.9, if I'm talking about it's from 1.9 till end. Yes, let's take from 2. We can make things easier, and this is our height. Okay, let's do for the rectangle. So length here is let's see what is the length. Straight line. So we have a constant speed at this point. So our value is 6.2, 6.3, 6.4. So value here must be 6.4, and breadth here is 1. So 6.4 meters. This is confirmed. But let's do for this. Okay. So why not we will apply the formula of a triangle here. Let's do for this. Okay. So this is 2, and here height is 6.4. So right here is 6.4, breadth here is 2. Because they don't want an exact value, they want an estimated answer. So we are doing our estimation. 6.4 plus multiply by 2, 12.8 divided
8.
by 2. This is 6.4. So 6.4. Now we will add up total distance. 6.4 plus 6.4. Let's see what is the answer.
12.8.
12.8. Yes. So this is the estimated answer. Now let's see what is in the marking. Or if we add some something like this, number of boxes. So it could be obviously more than 12.8. So if we are going to estimate the value, what do you think? What should be the estimated value? Our distance here is 6.4. This is 6.4. So the total here we have 12.8. But we have more space over there. So if you are going to add up some value, so let's take plus 5, for example. Let's take plus 5 in it. So it will be something like 17.8.
Yes.
Yes. So this can be our estimated value, 17.8. Okay. And let's look at the marking. They have given you the range of 16.5 to 17.1. Okay. So if we take lesser than 5, it should be more better. 4. So 16.8 is more better.
Didn't
Okay.
didn't they say up to 17.1, so it'll be 16.8, right?
Yeah, because it is under the range of the marking. 16.